from the soil is sandwiched between the two layers, and that gives me 1 unit. Similarly, in this case, you have AlSiCO10 unit, you have AlSiCO10 unit, and you have aluminium, you have hydroxide ion. They are sandwiched between the two layers, and this is 1 unit. And 1 unit is stacked over the another unit and goes on, gives a polymer. And this is the structure which you see in mica, in talc, and in white asbestos. Now in mica, 1 out of 4 silicon is replaced by aluminium. Out of 4 silicon, only 1 is replaced by aluminium. Now when aluminium is replacing silicon, silicon is tetravalent because silicon has S2P2 configuration. So it has 4 electrons, whereas aluminium S2P1, it has 3 electrons. So when you substitute a tetravalent by a trivalent, you need an additional cation, and that is why the potassium is present. So the potassium ion is present to neutralize the charge of silicon, because you are replacing a tetravalent atom by a trivalent atom. So in order to maintain the electrical charge, you need a monopositive charge like potassium. Okay, but now if 2SiO4 minus 4 oxygen, all the oxygens are shared. That means no terminal oxygen. So when each silicon is bonded to 4 oxygen tetrahedrally, and each oxygen is bonded to 2 silicon atoms, it gives rise to 3D network structure. This structure is shown by quartz, cristobalite, and tridimite. Will show 3-dimensional network structure, SiO2 structure. Because Si2O8 minus 4 oxygen gives Si2O4, which is nothing but SiO2 structure. Divide by 2. And if you have a sand, the sand which you see is this type of structure. It has a 3-dimensional network structure. It does not exist as an individual molecule. It exists as a polymer. If I take 4 units of SiO2, I get Si4O8. If I take 4 units of SiO2, I get Si4O8. Do I get Si4O8 or not?
Yes, sir.
And if I replace one of the silicon by aluminium, what will be the charge? 1 out of 4 silicon is replaced by aluminium. Then what will be the charge on this? 8 2s are minus 16, 4 3s are 12 plus 3. So you need a monopositive cation to neutralize the charge. And this is known as feldspar, which gives a 3-dimensional framework structure. This is different from this structure. Here you have SiO2. Here you have AlSi3O8. So one of the silicon is replaced by aluminium. When In the quad structure, when you replace one silicon by aluminium, then you get a three-dimensional framework structure. And this structure is present in feldspar, ultramarine, and zeolite. This is the material which I will discuss with you. It's a wonder material, zeolite. Feldspar. So what do you have? You have AlSiO8 unit with a negative charge and potassium with a positive charge. So there is an electrostatic attraction between AlSiO8 and potassium ion. If this unit has a negative charge, this has a positive charge, so there will be an attraction between the positive and the negative charge by an electrostatic attractive force. When you have such units, they are present in feldspar, that is on the rocks, ultramarine and zeolite. All of you have seen ultramarine. Do you know what is ultramarine?
No, sir.
When ultramarine, which is potassium aluminum silicate, contains some impurity like sodium and sulfide or polysulfide ion. This is called polysulfide ion. It gives a blue color. Have you seen Robin blue?
Yes.
The blue powder or the blue liquid
Yes.
which sells in the market?
Yes.
That has an ultramarine structure. So when you wash white cloth, okay, after washing it into the rubbing blue, it appears extra white because of the blue. And zeolite can be used for many different purposes as an ion exchanger. What is ion exchanger means? The potassium ion is exchanged with the calcium ion or the magnesium ion. When other metal ions exchanges the calcium potassium ion, that is why it is called ion exchange. It exchanges the potassium ion with the other ions, and that is ion exchange. Permutive is a synthetic zeolite. Have you heard permutive?
No, sir.
Have you studied hardness, softness of water?
Yes,
Yes.
Then you should know permutive.
used for purification.
If you pass water, hard water, what causes the hardness to water?
Salt,
Salts of calcium and magnesium.
Calcium, magnesium salts causes hardness to water. Not some salts. You have to be specific. So you have to say the presence of calcium, magnesium salt, it causes hardness. And when water is passed through zeolite, the calcium or the magnesium ion displaces potassium ion, and the calcium ion takes the position of the potassium ion, and so the potassium ion comes out from the column and makes the water soft. So since the water is being soft due to exchange of potassium by calcium ion, or the calcium by potassium ion, so it makes the water soft. And since zeolite exchanges ions, so it is called ion exchange. Molecular sieve. What is for sieve is used? Why sieves are used? To separate the fine particle from the coarse particle. The large particle from the fine particle can be separated by sieve, So sieve will allow only fine particles to pass through and not the coarse particles. So the molecular, the zeolite has a spherical cavity. Natural zeolite, they have spherical cavity. Their cavity is spherical in shape and the diameter is small. Since the diameter of the cavity is small, so it can absorb the small molecule and leave the large molecule untrapped. So it can absorb water, it can absorb nitrogen, oxygen, small molecule it can absorb, leave aside the large molecules. And that is how you can separate the small molecule from the large molecule. And that is why it is called a molecular sieve, which separates the large molecule from the small molecule. Shape selective catalyst. If you do, what is this compound? What is this compound? So if I do methylation of toluene, I will get a mixture of ortho, meta and paraxylene. The methyl group could be here, methyl group could be here, or methyl group could be here. So you will have a mixture of ortho, meta and paraxylene. Now, Mobile company in USA, they prepared a synthetic zeolite which is called ZSM5. This zeolite had, instead of a spherical cavity, it has a cylindrical cavity. It has a cylinder running through the zeolite. And the diameter of the cylinder is small. Since the diameter of the cylinder is small, so it will allow only a linear molecule to pass through, which requires minimum space. So para will pass through and not meta or para, not meta or ortho. Ortho and meta, they are branched. They require larger area. Whereas para will behave like a linear molecule, so it will pass through the channel, leave aside ortho and meta. And that is why this zeolite can distinguish the shapes of different molecules, whether it's a linear shape or a branch shape. That is why the word shape selective catalyst is being used.
Yes.
Why acid catalyst? Because aluminium is a Lewis acid. So, because of the presence of aluminium, it acts as a Lewis acid and it is used as a catalyst for dehydration reaction, where the water molecule is removed. One of the reactions is that if I take methanol and pass through zeolite, I get carbene. Can you see it?
Yes, sir.
And the carbene undergoes polymerization to get C10H22 fraction, which is gasoline. So the gasoline has, the fuel gasoline has C10H22 fraction. So the zeolite can convert methanol to gasoline by dehydration reaction to form carbene, and carbene undergoes polymerization and gives rise to synthetic gasoline. So you can see that how the zeolite can act as a Lewis acid catalyst for dehydration reaction. It eliminates the molecule of water from methanol, generates carbene, and the carbene on polymerization gives rise to gasoline. Why BaO2 is called barium peroxide? Na2O2 is called sodium peroxide. But PbO2 is called lead dioxide, MnO2 is called manganese dioxide. Why they are not called peroxide?
There is no peroxylate.
Can you see the peroxylate? Can you see the peroxylate?
No, sir.
You can see only if you do the X-ray structure.
Huh.
But what chemical test you can do to distinguish oxide from peroxide?
Peroxides give H2O2 when
Who told me, who told H2O2 gives it? It gives H2O2? Hey, let me see the ball. Peroxide on acidification gives hydrogen peroxide. Yes, 100% correct. A peroxide on acidification gives hydrogen peroxide. But oxide on acidification gives water. Yes. How do I know that it has given hydrogen peroxide and not water, both are colorless? How do I find out, detect the hydrogen peroxide in solution? Today, just 2 hours back, I discussed that question. Give a colorimetric test. 2 hours back, I discussed this. Then how do I know hydrogen peroxide is present in the solution or not? I add potassium dichromate plus sulfuric acid, I get the deep blue color. And the blue color is due to peroxo-oxo complex of chromium 6. So, this is the difference. How do I know the water is formed? Not hydrogen peroxide? Because if the color is not changed from orange to yellow or blue, that indicates the water is formed.
Yes.
There is another thing you can do. You can add anhydrous copper sulfate.
It will change blue.
Anhydrous copper sulfate is white. If it turns blue, you know the water is present. So if I get H2S2O8 at the anode and hydrogen at the cathode, and then I have not got hydrogen peroxide here. I got H2S2O8. H2S2O8 is called peroxo disulfuric acid.
Marshall's acid.
You know the structure of Marshall's acid?
Yes.
Okay. The O group is called the peroxy group. And this changes to sulfuric acid and hydrogen peroxide. So if I break a bond, what will happen? It will develop a negative charge, it will develop a positive charge. Because oxygen is more electronegative than sulfur. The water, H plus and OH minus. H plus will attack here, the OH minus will attack here. If OH minus attacks here, it gives you sulfuric acid. and hydrogen peroxide. So if you break the sulfur oxygen bond heterolytically, not homolytically, so that the bonded electron pairs move to oxygen, creates a negative charge. Sulfur becomes delta, sulfur becomes positive. The OH minus attacks the sulfur and H plus attacks the oxygen. So H plus is an electrophile, OH minus is a nucleophile. So nucleophilic attack at the electrophilic center. Okay, but today, industry prepares hydrogen peroxide by a different method. What is this called? When you have two benzene rings fused, you get naphthalene. When three benzene rings are fused, anthracene. And this is anthraquinol. Quinol is a paradihydroxy. When you expose to air, the 2-ethyl anthraquinol changes to, so quinol changes to quinone. You know what is the yield of hydrogen peroxide? Can you guess? Huh?
Cleansing wounds. Cleansing wounds.
What is the yield? I said. How much percentage of hydrogen peroxide is obtained by this method? It is more close to 1 rather than 5, I tell you. 5 is the upper limit. But then why the industry uses it? Because of two reasons. One is
Hydrogen.
you pass hydrogen gas over running nickel. As a catalyst, you get back the quinol. Expose the quinol to air, it gives you hydrogen peroxide. So once you prepare quinol, as long as you have the hydrogenation ready, it will go on and go on and go on. So you can repeat the process n number of times, and so that each time it gives you hydrogen peroxide. And this is the reactant and the product. This and this. They are insoluble in water. But hydrogen peroxide is soluble in water. So there is no separation problem. You wash it with water, the hydrogen peroxide will go into the aqueous layer, and the non-aqueous layer will be pure quinone. Again you pass hydrogen, you get back quinol. Again you expose to air, you get hydrogen peroxide. Hydrogen peroxide, 30% strength of hydrogen peroxide can be obtained by distillation under reduced pressure. Why under reduced pressure? Because lowering the vapor pressure, the boiling point is lower. Hydrogen peroxide boils at 152 degrees Celsius. So if you heat it to 152, hydrogen peroxide will decompose to water and oxygen. So you can't distill under ordinary pressure. When you lower the pressure, the boiling point is lowered, and then you can distill to get hydrogen peroxide, concentrated form of hydrogen peroxide. 30% strength of hydrogen peroxide is known as perhydron, which is an germicide. an antiseptic agent which will kill germs.
Yes, sir.
Hydrogen peroxide, it has a high dipole moment because of its non-planar structure. It has 3 atoms are in one plane, on the plane of the board. And this hydrogen is coming out of the plane, out of the board. And that is why it is called an open book structure. Just you have the open book structure like this.
Yes.